I ain't gonna worry about the rest of that. Okay, welcome YouTube, beautiful mind here. So we're gonna be doing a study session. This is gonna be a study session for our exam 2. This is week 8 at Morehouse College. Morehouse. So we're gonna be doing a study session for exam 2 over the second half of chapter 1, right? So let's hop over to here. Let's go ahead and let our brothers in. Let's see, who do we have? All right. I think I finally got to a rhythm where I'm not sharing so much sensitive information, and we can still do what we need to do. Keep it moving. Those are the two. We can let them in. All right, let's go ahead and let me share this with you guys so you can see. I'm gonna share my desktop, and feel free to unmute yourself and ask questions as needed. Okay. I'll be monitoring the chat and things of that nature. Yeah. All right. Is it slowing down? It kind of is. This one. We're gonna start here. Let me check and make sure that this is displaying properly. That looks good. Okay. Not that one. Okay. And I'll show the chat later. So if there aren't specific, let me check the chat one more time. When is quadratic? Just asking. When is it quadratic? Quadratic means the highest exponent is 2. So something like f of x equals x squared plus 3x plus 7, something like that. When the highest exponent is 2. That's the simple answer. Okay. So let's move you. Where can you be out of the way? I just need you out of the way. Let's move you over here. Okay. So we're going to start with section 1.4. We don't have a lot of time. We'll do the best we can with the time that we have. Again, if whatever kind of requests or questions you might have, use the chat or feel free to unmute yourself, and I'll be checking the chat periodically. This one asks us to write a linear function that has the indicated values. Okay, it's going to be a straight line, right? And these look like the x and y intercepts. Let me take some notes. So let's go paper. I usually like to write on graph paper. Okay. And you, my friend, can go here, and some water actually sounds fantastic. I'm gonna let you do what you do. Okay, so this is section 1. How do we thicken you up? Okay, I'm gonna have to go like this. Give me just a moment. I have to reload my notes. Usually I have to do that. It just slows down until we get into our rhythm. Okay, so I'm gonna start by taking some notes, and I know you guys can see my Pearson right now. Let's take some notes. So we're in section 1.4, a library of functions. This is a library of functions. Okay. This is question number 1 from the homework. It comes from section 1.4, and it's number 1 from the back of that section. Write a linear function. So if we're going to write a linear function, we're going to, here, let's write down what we're given first. We're given that f of 0 equals 10, and f of negative 10 equals 0, right? And we want a linear function. Okay, let's hop over to the tablet. I think if I go like this, it should update. There we go, that looks good. Okay. So if we want a linear function, right? A linear function is going to take on, I'm just automatically going to use the form that I'm comfortable with. I'm going to use y equals mx plus b, right? This is the one I'm going to use. You can also use the slope formula, which is y2 minus y1 over x2 minus x1. And just for good measure, the third formula is the point slope formula, which is y minus y1 equals m times x minus x1. For you all's purpose, you don't have to commit memory. You just need to have these functions ready to go and know how to use them, right? So we've been given these ordered pairs. It says when x is 0, y is 10. And when x is negative 10, y is 0, right? So I'm just going to go ahead and automatically label those x1, y1, x2, y2, right? The order doesn't matter. I mean, whichever x1 and y1 doesn't matter. What's important is that we're consistent, right? What I mean by that is, if this is my x1, this needs to be my y1. If this were my x1, this needs to be my y1, right? We just need to be consistent. Don't make this x1 and make this one y1. Like, that's not being consistent. Okay? So again, I'm a fan of using y equals mx plus b. The b is the y-intercept, so when x is 0, so I think we're given that one, right? It looks like our b, when x is 0, our y-intercept is 10, right? So we were automatically given that. So the other thing we do need to find is the slope, right? So let's find the slope. Again, one of my mentors would say every time we use a formula, write it down, and that just helps to remember it. I totally was about to say rememberize. I was going to say memorize and remember, and I was definitely about to say rememberize. And I thought about that. I was like, that totally is not a word. Anyway, y2 minus y1 over x2 minus x1. Let's plug in what we have. So our y2, that's going to be 0 minus 10 divided by negative 10 minus 0, right? Ultimately, that's negative 10 over negative 10, which is positive 1. So that's the slope, right? So it looks like we have a slope of 1 and a y-intercept of 10. So then the final equation that we can have, y equals, or maybe let's do f of x. F of x equals x plus 10, right? Now we can check and make sure that this satisfies both of those points. This is linear. Notice the highest exponent is a 1. And let's verify that these other points work, right? When x is 10, when x is 0, 0 plus 10 is 10. That checks out, right? When x is negative 10, negative 10 plus 10 is indeed 0. So that one checks out too. All right. So let's hop back over to Pearson. Let's do it here first. Pearson is here. And then we're going to hop to Pearson like this. So we got f of x equals, we got x plus 10. All right. That's what the result that we got. X plus 10. That's not a 10. Okay. Let me check the chat really quickly. Okay, that looks okay. And then it says choose the correct graph. So this is a diagonal line. Basically, it's the identity function, but we moved it up by 10, right? So up by 10 is this one. Has a positive slope, so that means when we trace it left to right, it should go up. So it should be C. I'm going to go with that. Okay. Let's just do the next one. And we can take Thursday to review as well. I know the exam will be available. We can just take that to answer questions. I'm going to skip this one because this is similar to what we just did. It's a little bit different, but it's close enough. You can figure it out. Find the intervals over which the graph is increasing, decreasing, or constant. So notice this is just going to be a diagonal line with a slope of positive 4 and a y-intercept of negative 2, right? So as we trace it left to right, it should be going up. Okay. As we trace this graph left to right, it should be going up. It has a positive slope, so it should be increasing. It's never decreasing. The function is increasing over the entire domain. So we say it's never decreasing, and it's increasing from negative infinity to infinity. Negative, that's not a negative. Infinity to infinity. Okay. Identify the intervals over which the function is constant. There is no, it's never constant, right? It's always increasing. Okay. Increasing, decreasing, or constant, right? If you have a graphing calculator, you can actually type this in. We can actually graph this using transformations. This is just going to be a parabola with the vertex at the origin, and then it's going to be stretched vertically by a factor of 3, right? But notice we did not move it left or right, nor did we move it up and down. We just stretched it vertically. So if we trace it left to right, initially it's going to be decreasing. Okay, so if we want increasing, it's going to be increasing from 0 to infinity, right? Like this one. And we're just using stuff that we talked about here. Like, you know, this is a basic graph. It's a parabola with the vertex at the origin. We didn't move it left or right, nor did we move it up and down. And all we did was stretch it vertically. So it's essentially the same graph. It's decreasing from negative infinity to 0. I'm going to go with this one. Uh-oh. So it's going to midterm grades, yes. This week at noon. When is that? That's Tuesday, Wednesday, Thursday. Shyster. Okay, that's fine. If it's due Wednesday, Tuesday, Wednesday, Thursday. Okay. I'm going to talk to him. If I need to submit something, I'll submit what I have. Okay. So it looks like our exam 2 might not be. I didn't want to do that. Might not be included on midterm grade because it seems like grades have to be put. I was gonna put midterms after you did the exam, but we might not have that luxury. He needs his name. I don't know who that is. I'm gonna tell him to put his full name. All right. Let's rock and roll. All right. Oh, it's constant. There's no interval where the function is constant, right? It's never flattens out. All right, let's keep it moving. The table is a complete representation of f. Decide if it's even, odd, or neither. Okay, so let me. I kind of want to write some stuff here. Let me hop back over here. I'm probably gonna have to close this out. Let me just close it out because I know I'm gonna have to. Give me a moment, guys. Hello? This is him speaking? Yeah. It's okay. Oh, wow. Thank you. What do you need? Stubs? Okay. Is can I do like bank statement or you need stubs? Okay. Okay. I'll get the stubs. All right. Thank you. Bye. I totally don't know why I'm trying. I don't know what I'm doing. I've just got some good news. So I'm geeking, but it's neither here nor there. Okay, sorry about that, guys. We are back in action, and I wanted to take some notes on this example. Here it is. Okay. So need a copy. What's the fastest way? Let me just write it. So let me take some notes. This is question number 5. Let's go here. This is question number 5 from this section. It comes from section 1.4, question 21. It says this table, so we have x versus f of x. We got negative 100, negative 10, negative 1, 0, 1, 10, and 100. I'm kind of out of space. I'm going to screenshot it. I was trying to avoid it, but I'm just easier. It'll just be easier to screenshot. It's going to take me just a little bit to screenshot it, but that'll be easier and more accurate and precise. So I'm going to just go like this. I need this. Come on. Can I just copy? Airdrop. So you're looking for, come on. There we go. Click. Awesome sauce. Hit done. All right, and then let's go here. Let's go like this, and yeah, it's okay. I need this to go away. I'm doing the thing. Okay, you are doing the thing. Give me a second, guys. Sorry about that. Technology's being a little bit temperamental, but that's how it always is, and I know what I need to do. Let's go like this. Photo library. This one. Add. Awesome sauce. All right, and let's see what are we showing here. So I was taking the notes, but I took the notes that I needed. So we're gonna hop here. That'll be fine. All right. So this is a screenshot that we just took. All right. Okay. So it says the table is a complete representation of f. Decide if f is even, odd, or neither. Right. And we have these numbers. Right. So here are the notes that I wanted to share. So the definition of what does it mean for a function to be even, right? A function is even. The definition of a function being even is when we do f of negative x, we should get back the original f of x, right? That's the definition of a function being even. The definition of a function being odd, let's write that a little bit better. A function being odd means when we do f of negative x, we get negative f of x, right? We do negative f of x. So that's what it means for a function to be even versus a function being odd. Another way that we can articulate even, that's the same as y-axis symmetry. Also, another way to view it is whenever we have x comma y, we also have even, so we have negative x comma y, right? It's like whenever we have x comma y, we also have negative x comma y. The y value stays the same, but the x values change. Another way to articulate a function being odd is origin symmetry. Origin symmetry. Okay. And another way to see this one is whenever we have x comma y, they both change. We also have negative x comma negative y, right? So for instance, what I mean by those last two articulations, so notice here, this first one we have is what? We have negative 100 comma 65, right? Then we also have 100 comma 65. So is that indicative of even or odd? Notice that the x's changed and the y's stayed the same, right? So if the x is changed and the y stay the same, that looks like the function might be even. Let's keep going and see if that happens all the way. We have negative 10 and 54. So then next we have is 10 and 54. Again, the x is changed, y stayed the same. Negative 1, negative 44. Oops. Okay. And then we also have what? 1 and negative 44. Again, the x is changed and the y stayed the same. That's indicative of the function being symmetrical about the y-axis. So if we were to plot these points, they're going to be symmetrical about the y-axis, right? The x values changed and the y values stayed the same. So that means this function should be even. This function is even, right? So let's hop back over to Pearson and see how do we do. I see we got about 30 minutes. We're going to take advantage of this time. So if we hop into Pearson, which is here. Actually, we need to go like this. Let's put this back. Pearson is here. So we said the function is even. Okay. Let me check the chat to see how you guys are doing. I don't think the student ever did. Let me check. Let me check the. Yeah, they're not doing it anymore. Okay. Let's go on to the next question. Let me see. So again, if we use the same dialogue, now notice here the x is changed, but the y value stayed the same. X is changed, but the y value stayed the same. So this one should be even as well. Okay. Okay, now we want to do a test for symmetry. We want to do algebraically test whether the function is even, odd, or neither. Okay, so let's see. This is question number 7 from this section. It comes from 1-4 question 25. We're going to say even, odd, or neither. Question mark, right? And then we got this g of x equals 7x cubed plus 2. Okay. So let's hop over here and go like this. All right. It's okay. We're not out of the woods, but all right. Oh, we want to do a test for even, odd, or neither, right? So what we do, again, to do this, all we do, we replace each x with negative x. All right, we replace each x with negative x, and then we simplify. So we're going to say 7 negative x cubed plus 2. But first, I usually like to start by replacing each x with a blank set of parentheses. Then again, I'm going to plug in my negative x there. Okay. If we have an odd number of negatives that are multiplied, the final result is going to be negative. So this is going to be a negative 7x cubed plus 2. Let's see. So let me see. Even if we factored out a negative, we can't get back to the original. Right? If we factor out a negative from all the terms, we still can't get any form of the original. So this is an example of something that's neither even nor odd. Okay. So let's go here. Get somebody in the chat. Number 10. Okay, we'll do number 10 next. Let's hop back to Pearson. Okay, we said it was neither. Check that one. All right, let's hop over to number 10. Numero 10 is this one. So this one says, give me a moment. It says the graph of a function is given to the right. Use the graph to find each of the following. It says the domain and range of the function. So what's the domain of the function? The domain is the very left to the very right. So as we go to the left, the furthest x value to the left is going to be what? This x is -1. Notice there are no arrows. Let's make this bigger, right? So the far left is -1. The far right is x is what, 7? So the domain, it goes from -1 to 7, inclusive. So I'm going to use square brackets, -1 to 7. Cross my fingers, awesome sauce, right? Notice I use square brackets. Remember, the square brackets mean we include those endpoints. Parentheses mean we get really, really close, but we do not include those endpoints, right? But here we do include the endpoints. The range is the very bottom to the very top. The lowest y value is -2. The highest y value is 4. And we actually reach those. So this goes from -2 to 4. Square brackets in this case, -2 to 4. Awesome sauce. X-Intercepts. Okay, X-Intercept is where it crosses the x-axis. Oh, I don't like this one. Okay, so we can find the slope, right? We can find the equation of the line, because it looks like it's not exact on anything. So let's find the equation of the line passing through these 2 points, and then find the x-intercept of that line, right? So I'm going to have to take some notes. This is number 10, numero 10. I'm going to get some paper. You seem like you're slowing down, so let's just go ahead and reboot you. All right. Number 10. Okay. So this is number 10. I just I want to find the equation of the line through the points. We got -1, -2, and the other one is 4, 4. All right. Let's hop over to the tablet and see what we're doing. Right? So the tablet is here. And for you guys, it's here. Okay. So we're going to find the equation of the line through these points, right? First, I'm going to start with the slope. So again, the slope being y2 minus y1 over x2 minus x1. And again, I automatically go x1, y1, x2, y2, right? So then if we plug in what we have, that's going to be, what, 4 minus a -2 divided by 4 minus a -1. That's going to be, what, 6/5? Okay, so that's our slope. Now we need to solve for our y-intercept, which is what, we're going to solve for the y-intercept so we can in turn solve for the x-intercept, right? Okay, so then we're going to be using y equals mx plus b, right? Let's plug in what we have. I'm just going to choose the second point because it just looks like it's more simple to use those numbers. There are no negatives. There's no negativity, you know. Anyway, so when y is 4, the slope is 6/5, and our x is 4. Y-intercept is the only thing we don't know. Okay. So then ultimately what we're going to get b equals 4 minus 6 times 4 is what, 24/5? That's what, 20/5 minus 24/5. What is that? -4/5. Right? So we got our y-intercept. So then the equation of our line looks like it's y equals 6/5 x minus 4/5. So now we have the equation of the line. We want to find the x-intercept. To find the x-intercept, we set y to 0, right? So if we set y to 0, then we're going to have 0 equals 6 over 5x minus 4 by 5. I'm going to multiply the left and the right by 5. So basically, I'm going to say this times 5, this times 5, and this times 5. I just distributed a 5 into all the terms, right? When we do this, the following happens. On the left, we still have 0. These 5's cancel. We have 6x there. These 5's cancel, and we have a 4 here. So then add and divide. Ultimately, x equals 2/3. 2 by 3, right? That's why I calculated it, because it wasn't like falling exactly on the money. Does this class let out at 3:15 or 3:30?
15?
Yeah, I think that sounds correct. Okay. Let me wrap this one up, and we'll do one more, and we'll call it a day. So we got the x-intercept was 2/3. Okay, let's hop over here. Let's hop back to Pearson. Let's see, how do we do? So a little bit involved. X-intercepts, if any, select the correct choice, fill in the answer. There is no comma to separate. I think it's just what, the 2/3. I think that's the format that they want, because I know formatting might be a little bit of a trouble here. Let's just do 2/3. Okay. Y-intercept. We have the y-intercept actually. The y-intercept of that same line was a negative 4/5. Ooh. Negative 4/5. Negative 4/5. Okay. I think that was it for that one. Oh, wait. Is there more? Continue. Intervals over which the function is increasing. So as we trace it left to right, initially it is increasing. As x goes from -1 to 4, it's increasing. And we typically use parentheses when we're doing increasing, decreasing, and constant. So we're going to go from -1 to 4. So as x goes from -1 to 4, the function is increasing. Okay. Let's continue. Decreasing is never decreasing. Okay, check the answer. Continue. Constant. It's constant as x goes from 4 to 7. So here we're going to say constant. My nose. As x goes from 4 to 7. Also time. Any kind of symmetry, it doesn't look like y-axis symmetry. It doesn't look like origin symmetry. I'm going to say neither. There's no symmetry going on here. That's it. Let me check the chat, see if you guys request any. If you don't request any, I'll let you go. We did number 10, okay? If there aren't any other requests, I'm actually going to let you guys go, and we'll kind of continue this on Thursday. With Tuesdays, I did get something scheduled. I said, hey guys, I'm not available. I got to leave by like 2:15 or something like that. They were like, that's okay. So I might be a little late on Tuesdays from here on to the end. We'll just have to do the best we can. My conversations with my other students are streamed on my YouTube channel, right? So you might have to rely on that and just keep reaching out. Okay, guys? All right, enjoy the rest of your day, and we'll meet back same place, same time on Thursday. Take care.
All right, thank you. Have a good one, all y'all.